Hello everyone, welcome to Chemoholics, your one-stop channel to make chemistry simple, easy and exam clear. So in the series of solving analytical chemistry problems, I came up with a new problem, and this problem is, are the equivalence point and endpoints the same? Justify your answer. This is a question from 2017 paper, and this question has 5 marks. So let's see how we are going to justify this question. Equivalent point and endpoint point. Okay, they are asking about, are equivalent point or equivalence point or endpoint the same? No, first of all, they are not the same value. However, they are close to each other. So to understand this, let's take an example of a titration where we are titrating HCl with NaOH base in presence of phenolphthalein indicator. So this is the phenolphthalein indicator. Okay, basically what is endpoint, or we can say equivalence point? Equivalence point means when HCl will reacts with NaOH, what will it form? It form NaOH, NaCl plus water, right? And at equivalence point, what will happen? The moles of NaOH should be equals to the moles of HCl. Okay, so this is the equivalence point. This is the, actually we can say this is a theoretical point. This is the theoretical point, but it is difficult to understand where this reaction has completed because we don't have any visual indication about that. So indicator we are using this indicator, phenolphthalein. Now what is endpoint? So when phenolphthalein has a pH of 0 to 3, this is the structure of the phenolphthalein indicator, and once this changes to 4 to 7 pH, the structure of phenolphthalein indicator is this, and that's what we are taking colorless during our titration. And once this pH cross the 7 and reach between 8 to 7, it will give you a pink color due to formation of this quinoid structure. And after that, from 11 to 14, again this solution has become colorless. So basically this generally used for the indication of the strong acid strong base titration. Now what is endpoint? Basic condition. So when the moles of NaOH are equal to the moles of HCl, the solution is going to be like neutralize. Okay, this is the neutral point. Let's say when we have already added that much number of moles of NaOH that is present in the HCl. So at neutral means the pH is 7, and at this pH the phenolphthalein indicator exists as a ring, this ring form, and there is no quinoid structure. That's why it is colorless in nature. So once for example, after this equivalence point, once we add a very small amount of NaOH. Okay, once you add extra NaOH, now there is no HCl to get neutralized. So this NaOH is going to react with this phenolphthalein, and it converts into this quinoid structure. Okay, and this quinoid structure will give you a pink color, right? So this is how we do this. We take the acid, we add a small amount of indicator, then this is the initial reading when we started the NaOH, and once the amount is reached, this is the final reading. But in experimentally we observe this reading when we observe the color as pink, but from here you can understand that there is some extra NaOH is needed to be added to get this pink color. So that's why this equivalence point point is not equals to the AND point. Okay, this is not equal. So, but they are closely related, close to each other, very close to each other. Okay, so when they are close to each other, so we can one more point about it. This equivalence point is the theoretical point which we cannot achieve because there is no method that can indicate at neutral pH, and endpoint is what, the first point where we observe the change in color or any other indication, that is indicator. Okay, so this is how you need to justify answer, and if you want to write your answer, take a screenshot of this. I have also written it here that equivalence point and endpoints are not same, although they are closely related in the titration. What is the difference? This is the exact theoretical neutralization point, which is difficult to determine. Okay, we cannot see it directly. Only it can only be seen by the stoichiometry of the reaction. And endpoint is the practical point where indicators show the changes and determined by the change in the color of the indicator, and this is the visible part. So indicators do not change color exactly at the equivalence point. They change over pH range, causing a slight difference. This difference is called titration error. Okay, also remember this value, titration error, that's the amount that extra we are adding. The AND point depend on the indicator sensitivity, so it may not coincident exactly with the equivalence point. So it has never happened that it is going to be coincident with the equivalence point. However, indicators are chosen so that their color change happen very close to the equivalence pH to minimize the error. So here one point is also there. We need to always select a indicator that give a very close equivalence point and end point. So this is a very basic condition for the choosing a indicator. So I hope that you are able to understand this question. So with that, I would like to thank you all for watching this video, and if you enjoyed this video, please do not forget to like, comment, subscribe and share.